Welcome children to another video session. Today we start chapter 10 of your book, Circles. Now circle is a very common thing for you. All of you know what is a circle. Some common examples of circle. A coin is a circle. Bangle is a circle. So you know what is a circle. Now how we define a circle? Now just see, this is a circle. How do we define the circle? We can define it. Now you see, this circle has this point on it, this point on it, this point on it. Now all these points, if they are equidistant from a fixed point, this collection of points is called a circle. So what is a circle? It is a collection of all the points which are equidistant from a fixed point. And what is the fixed point? The fixed point here is this one. Suppose this is O, and this fixed point we call the center of the circle. Now you see, all these distances are equal. So this collection of all the points which are equidistant from a fixed point, we call this a circle. And what is this fixed distance called? This distance from the center to the circle, we call it the radius. Now this is known to you. This is the center, this is the radius. Now let's see again. We have a circle, this is the center. P and Q are any 2 points on the circle. Okay, we join this PQ. What is this PQ called? PQ is called chord. PQ is called a chord of the circle. How many chords a circle can have? It can have many chords. It can have many chords. Now this one, is this a chord? Suppose I say AB. This is the center of the circle. Is AB a chord of the circle? Yes, AB is a chord of the circle because the end points A and B, they are all lying on the circle. So AB is a chord of the circle. Again, if you measure all the chords of the circle, you will find this chord AB, which is passing through the center, is the longest chord of the circle. Also, what is this AB? Since it passes through the center, or you might be knowing, AB is the diameter of the circle. So in a circle, diameter is the longest chord. Clear children? So a chord, if it passes through the center, we call it the diameter. A diameter is longest chord of the circle. How many diameters can a circle have? Infinite. How many chords can a circle have? Many, infinite. Now again see, this OB is the radius of the circle. This one AO is also the radius of the circle. So what is AB? AB is AO plus OB, that is R plus R, that is 2R, and AB is the diameter. So diameter is equal to twice radius. So this must, all of you must be knowing this, diameter is twice the radius. Again children, see, when you have a circle, this circle is dividing the plane. Now the board is a plane. It is dividing the plane into 3 parts. What are the 3 parts? First, any point inside the circle is in the interior. What is the second part? Outside the circle. And what is the third one? On the circle. So a circle divides the plane into 3 regions: interior, exterior, and on the circle. Okay children. Okay, next. So you understood what is a chord. This one, PQ is a chord. the endpoints lie on the circle. Now children, suppose again you have a circle. This is the center of the circle. Now, PQ is a chord of the circle. This points P and Q, it is dividing the circle into two parts. What are they? This is one part and this one is the second part. Each is called arc. Each portion is called an arc. This is the smaller one. The smaller one is called the minor arc. And this big one is the major arc. Okay children, so any 2 points on the circle divide the circle into 2 arcs. The smaller one is the minor arc and the bigger one is the major arc. Okay, again, this chord PQ divides the circular region again into 2 parts. This is one and this one is the second one. This small portion, each is called a segment. Each part is called a segment. The smaller one is minor segment and this bigger one is the major segment. Okay children, so now you understood what is minor arc, major arc, minor segment and major segment. Now suppose you join center, again you have a chord, join this. OP is the radius of the circle, OQ is again the radius of the circle, PQ is a chord of the circle. We are just joining the endpoints of the chord to the center. Now this one, this portion divides again the circle into 2 parts. This is one portion and this is the remaining portion. Now this portion is called a sector. So again, the 2 radii of the circle, they divide this circular region into 2 sectors. The smaller one is the minor sector and the bigger one is the major sector. Okay, so understood up to this children? So now we move on to a theorem based on chords. Okay children? Okay children, now we have the first theorem. It says equal chords of a circle subtend equal angles at the center. That is, equal chords of a circle, they make equal angles at the center. We will now prove it. For that, we have a circle. Suppose the center AB, CD are 2 chords of the circle. We join them. Now equal chords, so what is given? Given 2 equal chords AB and CD. This is given to us, equal chords. And to prove, what you have to prove? They make equal angles at the center. This is the center. This one, this chord AB makes this angle here. Chord CD makes this angle at the center. So we need to prove angle AOB is equal to angle COD. Proof. We consider these two triangles. In triangle AOB and triangle COD. Now we need to prove these two triangles congruent. Now what all do we find in them equal? Now just see AO. Is AO equal to OD? Is this one equal to this? Yes. Why? Because both are radius of the same circle, and we have seen before radius of a circle, they are all equal. So we write here radii. Radii is the plural for radius. Radii of the same circle. Similarly, check the other side. OB is equal to OC. Now this side is equal to this side. Yes, again the same reason, they are also radius. And AB equal to CD. Why? This is given to us. So we have 3 points equal, so therefore triangle AOB congruent to triangle COD. Which rule? All the three sides of one triangle are equal to that of the other. So we have SSS rule. And therefore angle AOB is equal to angle COD. CP, CT, corresponding parts of congruent triangles. Now children, we had to prove this. So we have shown if a circle has two equal chords, they make equal angles at the center. Is the converse also true? That is, if angle AOB is equal to angle COD, will AB be equal to CD? Yes. So the converse is also true. That is, if two chords make equal angles at the center, then the chords will be equal. So understood children up to this? Understood? Okay. So let it be up to this much for today. Thank you.